Hello there and welcome to this exciting plcgoods video tutorial series led by yours truly, Syed Raza Fattahzadeh. I am an industry experience and education lover with over 20 years of hands-on experience in the dynamic world of industrial automation. In this video, I am excited to introduce you to a very brief explanation of each of the 21 lessons in my course, CODESYS PLC Programming Tutorial for Beginners. The course is a complete journey made up of an impressive variety of 21 video lessons that will involve you deeply for a grand total of about 6 exciting hours. Lessons clarify the IEC 61133-3 standard, focusing on PLC brands such as Schneider, Beckhoff, and ABB. Beginning with basic ideas and progressing through programming organization units, variable types, and logic structures in ladder diagrams, the course provides a practical approach. The comprehensive journey examines Boolean operators, timers, counters, and extensive project development integrating with factory I/O and real-world industrial applications. Various programming languages, from function block diagram to structured text, sequential function chart, and continuous function chart are covered. Visualization capabilities using HMI screens are explained, highlighting RS instructions, switches, and meters. Especially, the course examines an automated warehouse project showcasing uncomplicated control logic for sorting and handling boxes. Whether you are a novice or aiming for advanced proficiency in PLC programming, my course offers a hands-on, comprehensive journey into industrial automation and control systems. So welcome joining me, and thank you for choosing to begin on this amazing learning adventure with me. Let's not wait any longer and start lesson number 1 right away. Lesson number 1 introduces a CODESYS PLC programming tutorial for beginners. The course focuses on the IEC 61131-3 standard, merging programming for PLC brands like Schneider, Beckhoff, and ABB. It discusses the industrial automation pyramid, highlights the study of programming organization units, variable types, and programming languages, starting with ladder diagrams. The tutorial guides viewers through CODESYS installation, project creation, and a simulated program. Highlighting following the rules, the course aims to simplify PLC programming, offering a comprehensive yet practical approach for learners. In video lesson number 2, the tutorial examines basic Boolean operators such as AND, OR, and XOR, explaining their application in creating fundamental logic structures. A simple ladder program resembling industrial circuit is examined and tested using CODESYS software. The video highlights the virtual nature of ladder program logic, similar to industrial circuits, with the left line representing a virtual power line. Common logic structures like AND, OR, and XOR are illustrated, showcasing their equivalent electrical circuits. The tutorial highlights the flexibility of PLCs in adapting program logic without altering electrical circuits. Additional PLC instructions, including set and reset coils, are introduced, showing their role in controlling outputs. The video concludes with a display of writing and testing simple programs in CODESYS, setting the stage for future examination of instructions like timers and counters. In video lesson number 3, the tutorial shows the integration of CODESYS with Factory I/O using KIP Server EX software to simulate and control a basic industrial process. Viewers are encouraged to download the demo versions of both software for hands-on learning throughout the course. The steps involved in establishing the connection are outlined, including configuring symbols in CODESYS for sharing, creating a virtual PLC with CODESYS control win, resolving potential software conflicts, and connecting to an OPC server with KIP Server EX. The tutorial details the definition of tags to identify selected symbols within the PLC program and showcases the design of an industrial process in Factory I/O linked to the PLC program through the OPC server. The connection settings and testings of the integrated system are displayed, providing a foundation for future examination of timer and counter instructions in the next lesson. Video 4 of the tutorial series investigates CODESYS, introducing and applying the 3 standard timers: on delay, off delay, and pulse. The on delay timer is showcased, measuring time between push button events. The off delay and pulse timers are introduced, each serving unique purposes. The tutorial highlights variable configuration and program testing, utilizing the help window for deeper insights. The tutorial progresses into a project involving start-stop push buttons, an emergency button, and various devices. Safety conditions are explored, showcasing logical design considerations. The necessity of normally closed contacts is highlighted, and viewers are encouraged to experiment and try the project independently before the next video, which will focus on utilizing timers to complete and test the project. In video lesson number 5, the tutorial series advances with the development of a full project in CODESYS. The tutorial introduces the control logic for an alarm siren, warning light, belt conveyor, and box emitter in Factory I/O. Pulse, on delay, and off delay timers are systematically utilized to sequence operations, ensuring precise control. Emergency conditions are seamlessly integrated with immediate shutdown mechanism, enhancing system safety. The tutorial highlights the critical process of linking the program to Factory I/O through CODESYS and KIP Server EX, facilitating effective control and monitoring. Throughout the tutorial, potential issues are addressed, providing a true showcase of the interconnected systems functionality. Viewers are encouraged to actively engage in the tutorial, applying the developed knowledge to enhance their programming proficiency. In video lesson number 6, the focus shifts to counter instructions in PLC programming, especially the up counter or CTU. This fundamental component counts upwards with each rising pulse on its input, activating an output when the counter limit is reached. The tutorial highlights the necessity of variables for counters and provides an overview of down counters and up counters, which count down and those up and down respectively. The tutorial then seamlessly transitions into practical testing using CODESYS, showing how to create a project, add an up counter, and simulate its operation. It offers insights into troubleshooting and testing through simulation and a virtual PLC. In video lesson number 7 of the CODESYS PLC tutorial, a practical project is investigated, including content instructions, RS and SR commands, and edge detection techniques. The project involves sorting boxes based on height using a like array with 3 sensors in Factory I/O. The tutorial guides viewers through the step-by-step programming process in CODESYS, highlighting the use of RS and SR instructions for start-stop requests and positive-negative edge detection. The program controls various actuators, including the intake conveyor, load actuator, and transfer actuators based on box types. An up-down counter is introduced for counting small boxes on the right conveyor. Emergency stop functionalities are integrated for immediate device shutdown. Testing is showcased using the simulation mode and connecting the program to Factory I/O through OPC server tags. In CODESYS tutorial video number 8, we focus on the ladder elements category covering essential ladder logic instructions. The move instruction facilitates variable value assignment, ensuring careful consideration of data types. Jump directs program execution to a specified network, enhancing program flow dynamics. The return instruction selectively halts program execution after its placement in organizations, functions, or function blocks. Branching tools, including branch start, end, and branch, offer systematic flexibility for sophisticated program design. In the function blocks category, we investigate rising trigger and falling trigger instructions for effective pulse-driven logic. The fundamental differences between set reset and reset set instructions are restated. Math operators like add, sub, mul, div, and the less than comparison operator enable mathematical operations and value comparisons. This comprehensive tutorial provides a foundational understanding of ladder logic instructions, enabling viewers to design and structure CODESYS programs effectively. In video lesson number 9, we investigate the remaining ladder logic instructions in CODESYS. Beginning with a benchmark project setup, we investigate the Boolean operators using XOR as an example and comparing it to manually implemented logic with simple contacts. Moving on to the other operators category, we examine the binary selector, multiplexer, and the widely used limit instruction for constraining variable values. The video proceeds to return to the move instruction, introduces the conversion tool for converting real numbers to integers, and presents the general category presenting the integration of instructions from the CODESYS library. The tutorial concludes by introducing a structured text language through a simple program, encouraging hands-on testing and discovering of additional instructions using the help window. In the video lesson number 10, we examine the utilization of functions in CODESYS to enhance program efficiency. Showing the idea to a practical project in Factory I/O, we designed a control system for a water tank with valves, level meters, flow meters, potentiometers, and digital displays. The challenge arises when the second potentiometer voltage range is incompatible with the discharging valve, promoting the creation of a function to handle the necessary mathematical transformation. The tutorial navigates through the creation of the function, explaining the definition of inputs, outputs, local variables, and the implementation of mathematical formula. The created function is seamlessly integrated into the main program, promoting mandatory and precision. The project is tested within Factory I/O, showcasing its performance. The tutorial concludes by highlighting the necessity of the connection process between the CODESYS program and Factory I/O with an accelerated performance of the process. Viewers are encouraged to refer to previous videos for a detailed understanding of the connection process if needed. Video lesson number 11 introduces the application of function blocks for improved program efficiency. The project involves independently controlling two tanks, each with separate fill and discharge processes. Presenting the project in Factory I/O, the tutorial proceeds to create a function block, highlighting its storage of local variables for successive scan cycles. The function block manages fill and discharge valves based on push-button states and pulse timers. Integration into the main program requires careful variable naming. A separate function calculates and displays remaining process times. Debugging insights are provided. The program is extended for two tanks, highlighting the importance of unique variables. The tutorial briefly reinvestigates the connection process to Factory I/O. Viewers are encouraged to enhance the project independently, showcasing the diversity of function blocks for systems with similar functionalities but different parameters. In the video lesson number 12, the transition to known programming languages is started. The focus shifts from ladder logic to function block diagram language. The previously showcased water tank control project is rewritten in FBD, highlighting the language's similarities with the ladder diagrams. Function blocks are created integrating elements like AND logic and pulse timers, showcasing the language utility. The conversion extends to functions maintaining similarity across the languages. The main program organization unit is divided into two similar parts, with one part reprogrammed in FBD for the second water tank. Debugging is addressed, ensuring proper variable usage. The simulation is conducted using Factory I/O, demanding connections with the OPC server. Issues with the second tank control are identified and resolved. In video lesson number 13, a brief overview of the structured text language is provided using the help window. The transition from ladder logic to ST is showcased through an extension of a practical project involving a buffer station in Factory I/O. The main program organization unit directs the switching between manual and automatic modes based on a selector. Global variables are introduced to facilitate communication between different parts of the program. The ST language's text and elements are explained, highlighting expressions operators, and assignment operations. The help window serves as a guide for learning ST commands and statements, including the if statement and common operators. The focus shifts to the development of the buffer station project in factory I/O, which involves conveyors, stop blades, and so on. The use of global variables becomes essential for connecting the selector, reset push button, and sensors. An up counter is utilized to count boxes with its functionality explained through the library. The simulation mode is utilized to test the selector and up counter, confirming their correct operation. The project showcases the application of ST language in PLC programming and sets the stage for further investigation of CFC and SFC languages. In the video lesson number 14, the completion of the buffer station project is detailed. The manual program organization unit is established, allowing control of the buffer and exit conveyors through push buttons. Global variables are introduced for these controls, and the structured text code is crafted to manage conveyor operations based on button status. Eventually, an automatic control program is developed. The code includes conditions for controlling the exit conveyor, the stop blade, and buffer conveyor, including sensor inputs and system status. An up-down counter is utilized to calculate box movements on the second conveyor. The code undergoes error correction and execution. The buffer station project is regarded complete with potential enhancements suggested. In video lesson number 15, a new project is introduced using the continuous function chart language. The existing sorting station project is tested, showcasing manual and automatic modes. The sorting station in factory I/O involves 3 automated sorting systems, conveyors, and a vision sensor providing product categorization. The CFC language is chosen for programming, and a global variable list is created to connect equipment within factory I/O. Program organization units for manual and automatic codes are established with a highlighting on a variable toggled by a start, stop, and emergency buttons. The CFC program structure is explained, showcasing logic implementation for mode control. In video lesson number 16, the sorting station project is further developed using the CFC language. The focus is on controlling the entry and exit conveyors, programming the sorting arms, and displaying product counts on digital LED displays. Remarkable features of the CFC language are highlighted, including the ability to streamline input connections and adjust program execution order. The tutorial covers adding functions to the CODESYS library, such as the blink function for creating blinking light. Additionally, FPD language is used for the POU managing digital LED displays. The tutorial ends with compiling the project, configuring symbols, and preparing for OPC server-based connections to factory I/O. In the video lesson number 17, the focus shifts to Sequential Function Chart or SFC language basics. The tutorial begins by creating a new SFC project, explaining essential elements such as steps, transitions, and actions. The significance of an initial step is highlighted, and the video guides through constructing a simple SFC program with entry, main, and exit actions. Qualifiers like non-stored, reset, and set are introduced for effective step control. Practical simulation showcases the program's behavior using the CODESYS simulator. The tutorial highlights the use of branches, transitions, and replacement structures. Towards the end, it investigates rewriting the SFC program in a structured text language, showcasing the diversity of CODESYS. In video lesson number 18, the focus is on Sequential Function Chart or SFC language essentials and a practical project implementation using Factory.io. The tutorial covers the creation of variables, explaining main, entry, and exit actions, and presents duplication modes for steps. It investigates the generation and use of SFC flags, highlighting two methods, implicit and explicit, for transitions, showcasing the SFC language suitability for tasks requiring a specific order. A transition is implemented with an AND logic, and a comparison between SFC and other languages is provided. The video concludes with the beginning of a practical project in Factory.io, introducing the automated warehouse system with conveyors, sensors, and a stacker crane. In video lesson number 19, the focus is on simulating an automated warehouse system using Factory.io. The tutorial starts by reviewing the connection process between CODESYS and Factory.io, highlighting the use of an OPC server for communication. A new project in Sequential Function Chart or SFC is created, and a global variable list is established for connecting with Factory.io equipment. The connection process is showcased, ensuring the coordination of variables. The tutorial introduces a new POU to control the overall system sequence based on a start, stop, emergency, and reset conditions. The main POU is developed to handle the warehouse sequence, including loading, receiving, and transporting steps. The use of RS instruction and logical operations is explained, and a macro is created to contain related steps. In video number 20, the tutorial concludes the finalization of an automated warehouse project. The focus shifts to the process of placing transported boxes onto empty racks, introducing a new macro that directs three essential steps. These steps involve controlling actuators such as forks ride, resetting the lift actuator, and subsequently turning it off. The tutorial highlights the implementation of fixed time durations for specific sequence steps, ensuring precision. The program undergoes collection, and the simulated warehouse project is showcased through Factory.io. Additionally, the tutorial introduces an extended section providing two emergency and reset scenarios. A new POU is created to manage these conditions using a flag and jump instructions for controlled program flow. The tutorial concludes with testing the project, highlighting its sensitivity to emergency and reset inputs, and it suggests the potential for extending the project to collect additional sequences. In the video lesson number 21, the tutorial expands the automated warehouse project by integrating visualization capabilities for human-machine interaction or HMI. The video begins with a showcase of a basic program displaying the use of RS instructions to control outputs. The tutorial then investigates the visualization option, discovering various objects like lamps and switches to create a simple HMI screen. The tutorial content progresses to show the entry and display of numerical values using potentiometers and meters. Transforming to the automated warehouse project, the tutorial introduces an extended sequence for uploading boxes controlled by a selector. The HMI screen is designed to reflect the project states, including push-button lights and a visual representation of rack occupation. The tutorial concludes by explaining the added programming elements, detailing the use of Boolean variables and arrays for efficient visualization. Highlights is placed on the design settings for objects, providing insights into creating effective screens for different projects. Conclusion. My CODESYS programming course, composed of 21 lessons, investigates deeply into CODESYS software and its application in industrial automation. Each lesson offers practical insights, covering topics from basic ladder logic to advanced principles like FBD and SFC languages. The course showcases seamless integration with factory I/O and human-machine interfaces, highlighting effective communication in industrial frameworks to allow you to confidently tackle real-world automation situations. You can access each full lesson video for free by clicking on the matching link provided in the video description right below. To master the skills of a professional PLC programmer, carefully observe, practice, duplicate, and copy or imitate each topic covered in my video lessons on your PLC or simulator and test it for yourself. Discover further by purchasing the complete video course at www.plcgoods.com, where you will unlock following priceless and important benefits. 1. Code lessons that enhance your understanding or insight of each program logic. 2. Direct access to my WhatsApp channel for customized and specialized support. 3. Ask questions and receive guidance tailored to your needs. Thank you for being a part of this educational journey. These video lessons are carefully crafted to clear the road for your future success in industrial automation. Best of luck, and may your programming activities be both fulfilling and rewarding. See you. Take care.